Hello everybody. In this video we will try to get a brief introduction about the mechanism of breathing. Actually, normally, each minute in your life you are breathing from 12 to 20 times. This is normally at rest conditions. It is not anything. Your lungs receive air, takes the necessary oxygen for you, and throw out the extra CO2 that you do not need, and you exhale this air each minute around 16 times without your control. How does this happen? Actually, the mechanism of breathing specifically is one of the topics that is extremely related to the physics and physics law. Most of us studied at high school boiled law. What was this law about? It describes the relation between the pressure and volume. It says that if we multiply the pressure by volume, you will get a constant. What does this mean? It means that if I increase the pressure, I have at the same time to decrease the volume to get the same constant at the end. And the opposite. If the volume increases, I have to decrease the pressure to get the constant. One of the very common kind of the problems that we get used to solve is the piston problem. In this case, if you decrease the volume of the piston, the pressure of the gas will increase to keep this constant the same. Okay. How does this law and this relation is related to respiration? Here is your thorax. What's happening? This is inhalation, and this is exhalation. What's happening for you to inhale, to get air inside your lungs, is that your diaphragm contracts. The diaphragm is the most important muscle for respiration. Actually, if the diaphragm gets paralyzed, you will lose about 70% of the respiration especially. So, this diaphragm contracts, so it moves down. And this intercostal muscle between the ribs also contracts, so they are invading the ribs outside your lungs. What you are trying to do, you are increasing the volume of your thorax. I increase the volume, so the pressure will decrease. The pressure in your thorax will be less than the atmospheric pressure. So as for the air to get into your lungs, you are inhaling. What happens is exhalation is the opposite. The diaphragm relaxes, so it moves to its normal condition. It moves upward, and the same intercostal muscles, they relax, so the ribs move inward, so the volume of your thorax decreases, and the pressure increases more than the atmospheric pressure. So the air goes out from your lungs. Between these two processes, you got what you need from the oxygen, and you get out the CO2 that you do not need. And actually, this gas exchange, there will be a separate video to explain this process. As you see, in inhalation, in the inspiration process, we are contracting muscles, so we have to pay energy to perform this process. This process is active process. On the opposite, in exhalation, in the normal state, in the rest state, what happens is that those muscles only relax. So it's a passive process. I do not need to pay energy. Not only because those muscles relax, but actually because the lung itself tends to recoil. It tends to decrease its volume. This is a very complicated topic, lung compliance. And lung surfactant. If you want to understand more about this part and how the lung responds to the increase or decrease in volume, you can read about those two topics. It's very interesting, but it gets more deeper in physics. very small question. Here is here is the same picture, but different view with side view. Again, here is inhalation. This is inhalation, and this exhalation. In inhalation, the diaphragm contracts, so it moves downward. The intercostal muscles here contract, so they move the ribs outward, so the volume increases and the pressure decreases. So the air moves into your lungs. In exhalation, the opposite, the diaphragm. لا لا. So the pressure decreases and more than become less than the atmospheric pressure, so you can inhale air. And the opposite for exhalation. In exhalation, your diaphragm relaxes, so it moves upward, and your ribs also relax, so the ribs intercostal muscles relaxed, so the ribs moves inward and decreases the volume of your thorax, so the air moves outward. The opposite is in exhalation. In exhalation, your diaphragm relaxes, so it moves upward, and your intercostal muscles also relax, so the ribs move inward, decreases the volume of your thorax, and so the air moves out of your lungs. But there is a very small question. Do you think that when you are at the beginning of the semester, there is no يعني بعدين there is a very small question. Do you think that at the beginning of the semester there is no many things to study? You are very relaxed. Do you think that in this case you need as much air for respiration as in this case you are late on the lecture? You need to run to catch your lesson? Definitely no. The amount of oxygen you need in this case is much less than that you need in this case. There are different mechanisms to give you the more oxygen you need. One of them is to increase the respiratory rate. Of course, it won't be from 12 to 20. It will be much higher than that. Another thing, other thing is that you can increase your heart rate. Your heart rate. One of the other things is that actually your lung is not adapted to only get one specific amount of air inward and outward. Inward and outward. There are different volumes of air that the lung can deal with. Those lung volumes and lung capacities are very important in diagnosis. Let's have a look about them in this case. In this case. They are not difficult. You can know them easily. This is the volume of air you inhale or you exhale. Don't care about the number itself. And here is your respiration. This is the normal respiration. Normal, it's a rest state. You inhale this amount of air and you exhale the same amount of air. This volume is called tidal volume. The normal amount of volume that we can exhale or inhale in the rest state. In case there are different conditions you are running, you need more oxygen, your lung can actually take all that extra volume, about 5 times your normal tidal volume. This extra volume is called inspiratory. It's called inspiratory reserve volume. Inspiratory from inspiration or inhalation reserve extra and volume. Of course, if you inhale more air, you will exhale more air. This extra amount of air you can exhale is called expiratory reserve volume. But there is something important. In all cases, whatever the condition, all the time there will be a specific amount of volume will not leave the lung. Whatever the condition. This is called residual volume. Actually, if you lose this volume, your lungs will collapse and won't be able to respire air anymore. So it's very important, and it does not change or go out of the lung. Those are the volumes. They are only 4: inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume. There is another thing called lung capacity, and actually, simply the capacity are the addition of two volumes. If you add the inspiratory reserve volume with the tidal volume, you will get something called inspiratory capacity. The capacity is there is another important thing is called capacity, lung capacity. What is the capacity? The capacity is There is another important concept, it's called capacity. What is capacity? It's simply the addition of two or more of the lung volumes. For example, if you add the inspiratory reserve volume with tidal volume, we get something called inspiratory capacity. The total capacity that the lung can inspire from air. If you add those two, if you add inspiratory reserve volume with residual volume, you will get functional residual capacity. If you add all the volumes of the lungs except the residual volume, you will get vital capacity. And finally, the last one is if you add all those volumes, you will get total lung capacity. So we have only 4 volumes that you need to know. Normally, what you inhale or exhale is tidal volume. The extra amount of air that you can inhale is respiratory reserve volume. The extra amount of air that you can exhale is respiratory reserve volume. The volume that's always kept in your lungs is residual volume. Addition of respiratory reserve volume to tidal volume is respiratory capacity. Addition of respiratory reserve volume to residual volume functional residual capacity. All the lungs except the residual volume is called vital capacity, and all the volumes is called total lung capacity. This is a fine picture about the same concept, the lung volumes and capacity, and actually show us how the lung is able to adapt to different conditions. This is normally the tidal volume about 0.5 liters. Normally, you are inhale and exhale 50 milli of air. You can increase this amount 5 times to 2.5 liters in respiratory. It's inspiratory reserve volume, inspiratory reserve volume, and you can increase the amount you can exhale to 1.5 liters expiratory reserve volume, and this is the residual volume. All the time it will be kept inside your lungs. Residual volume. Addition of tidal and inspiratory reserve volume is the inspiratory capacity. Addition is the inspiratory capacity. Addition of expiratory reserve volume with residual volume is functional residual capacity. Addition of all those volumes except residual volume is vital capacity, and the total of all those volumes is total lung capacity. This is for today. Next video we will try to explain the gas exchange, what's happening inside your lungs, how do you get out the extra CO2 you do not know, and how you get your oxygen. Thank you.